Okay. Hello, students. Once again, you're welcome to Waidsum University. This is networking essential management, and this chapter 4, part 3. You know, the issues with this chapter is that one chapter has about 6 to 7 PowerPoints. So the chapters are huge and they're big. Okay, so this semester we are doing chapter 1 to 8 for this semester, chapter 1 to 8. Next semester we are doing chapter 9 to 16 next semester. Okay, this course will be taken in 2 semesters. Okay, so networking essential management 1 for this semester, and networking essential management 2 for next semester. So this chapter, chapter 4 part 3 is wireless networking. Now let's take a look at what we mean by wireless networking quickly. Now, without much ado, let's begin. We say that what you see on the screen above is an example of both a wireless network, what we call WLAN X wireless network. You can see the wireless. This aspect is called the wireless network, and then you can also see the wired network. This is a wired network, okay, with a hub. Okay, the wired network here up to this level, and then we connected this one to a hub, from the wired network to a hub, and then to an access point. These are antennas. These are rooftop antennas, okay, to carry the signal. And then this access point is to establish communication between this wireless local area network and the wired network. That's the job of this access point. Okay, so what you see is an example of a basic 802.11b wireless LAN configuration. Okay, now we say what you see here is that each PC is outfitted with a wireless LAN adapter. Every PC here has a wireless LAN local area network adapter. Every PC has a LAN adapter, okay, that enables an establishment of a connection using the link from this access point to establish a connection from here to the wired network, to establish a connection from the wireless network here to a wired network here. Okay, so every PC has a wireless adapter that helps to establish a link to the access point, and from the access point it will determine where the message is supposed to go. This client computer, whenever it wants to send, let's say PC A wants to send message to PC D in the wired network, the PC A is in the wireless network and wants to send a message to a PC D in the wired network. What happens is that the message will first of all be sent through the network adapter to the access point being accessed by this access point will establish the data packet, and establish a connection and determine the route or the PC, the destination of this data packet that is sent from PC A. So this access point will therefore use it with the help of this hub or a switch or a router to send this data packet to PC D where it is originally designated. Is that okay? So first of all, wireless adapter, which is found in every wireless LAN adapter, is a device that connects the client on the wireless media to the wired media. Okay, a device on the wireless media to the wired media. Now the media is typically a radio wave. Okay, the message is converted, modulated to a radio wave, which is accessed by this access point, and therefore all word delivery through to this hub or switch. The hub or switch will now send it to the destination because it has been marked with a MAC address, with an IP address. It has been encrypted for a particular PC that is supposed to, the packet is supposed to be, data packet is supposed to be delivered to. So that's how, if a PC on a wireless network is sending a message, PC A on a wireless network with a wireless adapter, and sending a message to a PC D on a wired network, a link will first of all be established between this antenna and this access point, and the access point with the designation, with what is the MAC address, the message, the encryption, the message on the data packet we will be able to be locate the destination address where it's supposed to be with a PCD, and the message will be delivered in that respective manner. Is that okay? Now, since this is 802.11b, so the channel has a bandwidth, a bandwidth of 2.4 gigahertz. ISM. ISM is both instrumentation, scientific, and medical band. So it covers instrumentation bound in electrical engineering, scientific bound, and medical bound. Okay, so that's the first phase of this one. Let's move ahead quickly. Now we say the second phase is the wireless medium can also be infrared, not only radio frequency, not only RF. Okay, the wireless medium can also be an infrared. So not only RF frequency, although infrared is not so popular, we normally use the radio frequency wave. Okay, we normally use it. We transmit data through using an RF medium. Okay, but however, not only the RF wave that the data packet can be sent through, it can also be sent using an infrared. Although the infrared, like I said, is not super popular. Now, the services provided by the wireless LAN adapter are what? What does this wireless LAN adapter? You know, every PC, a wireless PC, has a LAN adapter. Okay, now what are the job it does? What are the things is supposed to do for you? Now, the first job it does for the network is the delivery of the data. So the LAN, you know, it's the wireless LAN adapter is the one that establishes a link between the PC on the wireless network to the access point that is connected to the wired network. Remember, no wireless data packet can go to a wired data packet if there is no access point. The access point, the sole purpose of the access point is to establish a link between the wired network and a wireless network. So the first job of the LAN adapter helps to establish a link to the access point. Okay, the access point is to establish the link between the two networks, the wired network and the wireless network. Why the LAN adapter, which is found in your PC, the job are one, to deliver the data to where you are sending it to. Number two is to create authentication, and number three is privacy, to provide that specific privacies that every of your DC require or desire. Okay, so that's the job of the LAN adapter: provide the delivery of the data, provides authentication, and privacy for the network. Now, like I said earlier, the connection to a wired LAN, local area network, is only possible because of the introduction of what we call the access point. Without the access point, which is this one, this is the access point. Without this access point, we cannot connect the wireless LAN to a wired LAN. We cannot connect the wireless, this is the wireless one. We cannot connect the wireless LAN to a wired LAN. So we need an access point to create that. It's like a gateway. The access point is the gateway that helps to create that linkage between wireless network and a wired network. Is that okay? So that's it. The purpose of the access point is to provide a bridge between the wireless LAN and the wired network. We already established that. Now, the physical cable connection, like we normally use to create a connection between the access point and the switch or hub, and from the switch or hub to the LAN to the wall plate of the wired network, are usually what we call the RJ45 Cat 6 and Cat 5E. The RJ45 Cat 6 and Cat 5E. That's what we normally use, the cable that we normally use. Is that okay? Now let's move on quickly. Now we've already established the access point. We've told you this is our access point. Okay, this is our access point. Without this access point, there's no way we can connect the wired network to a wireless network. Is that okay? So we've already established that that statement. Now let's move on quickly. Still on that, say like we have already explained, we say if computer A, PC A in a wireless network wants to send a data packet to PC D on a wired network, which is a destination in the wired LAN, the PC A first send a data packet over the link, the wireless link Okay, it will first send the data packet over the wireless link to where? To the access point. The access point recognizes the sender of the data packet as a host in the wireless LAN X. This access point is the first to establish or recognize the data packet and recognize the host, the sender. Recognize the host, okay, as a host in the wireless LAN. So the access point recognizes the PCA as the host. That this PCA is the host, is the sender, is sending this data packet, okay, to a wired LAN. To a wired LAN. LAN means local area network. So this PCA in the wireless network send a link, okay, establishes a link with the access point. Now the access point recognizes the sender of the data packet as a host in the wireless LAN X and allow the wireless data to enter the access point. It will allow it because you already established a link. There's a link between the access point and the adapter, okay, the network adapter in PCA. So there's already a link that is already established. So the access point recognizes this PCA as a host, and it will allow this host to bring whatever it has. It say bring it on, okay, bring it on. Okay, what is in it? It's like a post office. The access point is like a post office. When you're sending a letter, you send it, you establish a link with a post office. You send the letter to a post office. The post office takes it. It recognizes you as the sender. It tells you to write your sender address and the receiver address. Okay, so then they will forward it to the destination. Okay, the access point is like a post office. It's also like a bank. For example, if you send it Western Union or MoneyGram, okay, the bank can be a gateway. It will receive it. It asks you to put the sender address or the receiver address, and then they will establish a link, and then you are the host, and then they will forward it to the respective destination where the money is supposed to be sent to. The money will be wired there in the country that is supposed to be sent to. So it's the same understanding. The access point recognizes the data packet from PCA as the host. Oh, okay, PCA is the host. It's sending something to PCD in a wired network, and first of all, it established a connection, and it also established an understanding and an association. And then once that is established, then it will do the necessary and forward it with every other things that it needs to be put in it. The MAC address, recognize the MAC address of the destination address of the PC that is supposed to be sent to, and the header that is supposed to go with it, and every other thing that's supposed to go with it, and then you will send it to the respective destination of that computer. Is that okay? So let's move on quickly. Now, what does it use? What are the rudimentary that the access point use in order to, first of all, to establish a link, and apart from establishing a link, in order to recognize the destination where the data packet is supposed to be sent to. Now, the question that should come to our mind at this point in time is, how does the access point know that the wireless data packet is being sent from a client in a wireless? How does it know that the data packet is being sent for a particular, because PCA is not the only PC. It's not the only PC in the wireless network. How does he know that, oh, this is the client that is sending it? How does he know it's PCA? How does he know it's PCA? Why did the access point not mistaking it for PCB or PCC? Why does he not make that mistake? That, okay, this is coming from PCA or PCB. Now, this is what happens. How he recognizes that it's being sent from a particular client in the wireless LAN is that the answer is simple. First of all, the 802.11 wireless LAN devices use what we call the SSID. The 802.11 wireless LAN devices uses an SSID to identify what wireless data traffic is allowed to connect to the network. What wireless data traffic is allowed to connect to the network. That's the first thing. Now, what is this SSID? The SSID is a wireless service set identifier. It's like a password. It's a password, not like a password. It's a password. So the SSID is a wireless service set identifier. That's okay. This password is only coming from a PCA, because every PC has its own unique identifier ID, SSID. Every PC has its own unique SSID. Now, the SSID is just a password that enables the clerk to join the wireless network. Once that happens, an association is established. An association is established. What we call association is established. Once the access point can recognize the SSID of a particular PC, then an association is established. Now, the access point uses the SSID to determine if the clerk is to become a member of the wireless network. If you want to become a member, that means if you are requesting, oh, please let me in, let me in, let me in, I want to be a member, let me in, and then the access point, we establish an association between the access point and the particular PC with using its own network adapter. Is that okay? To the access point. Now, the term used to describe that a wireless connection has been established is called an association. So the term that is used to describe the access point establishing a link between itself and the PC in the wireless local area network is called association. Now let's move on quickly. Now this is an example of the information that you will see that is displayed on a wireless adapter cursor port. If you go to your setting, once an association is established in a network, and you go to the setting, if you go to what we call the management software, management software system, or the wireless management software, and you will find if a connection or an association is established, the information will be displayed as shown on this screen. The information will be displayed as shown on this screen. Now, what you see here is a MAC address. You can see the MAC address tells us which particular PC has that data packet. Which particular PC has that data packet. You can see it's ROMI from channel C's is associated, meaning it has established itself as a member of the network. It has associated itself with the access point. Okay, you can see the signal strength or the signal availability. Number of available access point 1. You are using access point 1. So this is what is displayed. The information you've just seen is what is displayed when you access the wireless adapters cursor ports. Okay, wireless. You can go to your setting. When the PC is connected to a wireless network, you go to your setting. I go to network. From there, go to your wireless adapter cursor port, and then you see once your PC is established and you're about to send anything, then you will see this kind of information be displayed. Okay. Now, what you see here is that the text indicates that a connection has been made between the parent access point. The parent is the access point. Remember that the parent access point and the MAC address for the PC. Okay, for the parent is this one. The MAC address is 004096259014. This is the MAC address of the parent of the parent, which the MAC address of the parent, which is the access point. Now the text indicates that the MAC address has been added. What you see here, what is showing here, once this is displaced, is showing that the MAC address has been added to the access point. So the MAC address of the PC has been added to the list of system that has associated with the access point. It has been added to the list of systems that has been associated with the access point. This type of information is typically available via the wireless management software. You go to wireless management software, you'll be able to find this type of information in your PC. Okay, now this is from the wireless management system. You see the hyper terminal. From the hyper terminal, you see all the association that has been made. You see all the association that has been made with regards to the access point and the PCs that are accessing the wireless PC that are accessing it. The access point use the associations to build a table of users. So these are table of users that are trying to access the access point and trying to send a signal or message or data packets to respective designated destination in the wired net LAN. In the wired LAN, is that okay? Now the association table lists the MAC addresses for each networking devices connected to the wireless network. Okay, it will list all of them as you see. It will list all the MAC addresses of all the PCs that have been connected. In this regard, we say that has been associated. That has been associated. Now, the access point then uses this table to forward data packets between the access point and the wireless network. So whatever has come from the client, which is the wireless network, the access point will access it and know where this data packet is supposed to be sent to, and then the access point will establish a link to the destination in the wired network. Now the wireless client adapter will also notify the user if the client has lost an association with the access point. So if you lost association with the wire, maybe due to network problem or whatever it is, if you lost a connection with the access point, you will also be notified that you have lost your association with the access point. Is that okay? Now let's move on quickly. Now let's quickly take a look at the connections, how the data packet from one wireless is being linked to another set of wireless or another set of wired network. We have what we call a wireless bridge being used, with this antenna that is happy to transmit the data packet or the signal from here to the other side of the building or to another building where you have where the data is supposed to be sent to, the data packet is supposed to be sent to. So the hub here contain or has what we call the antenna, that helps to transmit the data packet from this building to the next building, from building 1 to building 2. Now a wireless bridge is a popular choice for connecting the LAN, but it's not only bridge we use switch, and most especially we use router for WAN we use router, but for LAN we can use switch, so we can use switches and bridge to connect for running similar network protocols. Okay, now so we say together, even if the LANs are miles apart, still you can send the packet from this building to another building, as long as you have your antennas, you have your bridge, you have everything in place. Is that okay? Now this first one, this type of connection from a straight loop, sending your signal or your data packet from this building to the next building is called what we call the point-to-point wireless bridge. This is called point-to-point wireless bridge. On the other hand, if you look at figure B, we have what we call the point-to-multipoint. You can see from this building A, the data packet it will be sent from building A to building B and building C. The data packet will be sent from this building A to building B and building C. Now this is point-to-multipoint. So it can go here and go here, either concurrently or simultaneously or whatever as the case may be. Okay, so this type of establishment is called point-to-multipoint wireless bridge. Point-to-multipoint wireless bridge. Now let's move on quickly for the sake of time. Now we have what we call the connection to the wired LAN. Connection to a wired LAN. Now you have one wired LAN here. At the downside, you have a wired LAN here. This is not a wireless and wired LAN now. This is wired LAN and another wired LAN. So two wired LAN. So this is the rooftop. These are the rooftop. You can see antenna here. This is a bridge, or you can use a switch. It's not only a bridge. You can use a switch. Use bridge, hub. The hub is old fashioned. Hub is not giving that creativity and flexibility, as it were. We most likely use a bridge and switches in the case of LAN. Okay. Now you have a bridge connected with an antenna on the rooftop, and then also similarly you have another bridge in a wired LAN. This is a wired LAN with different PCs designated to it, with different PCs that are connected to your wired LAN, to the wall plate of your wired LAN, and there is a bridge with an antenna on top of it, and this is another wired LAN with a bridge with an antenna on top of it. So all signal from here will be transmitted and will be received by this antenna, and it will be sent to this wired LAN. So these are two wired LAN, and how signals or data packet from this wired LAN local area network to another, the next local area network. This could be two next building or street to another street, or as long as the area is not too a wide area, it's just we call it a local area network. But if it's a wide area, it becomes a wide area network. Okay, and that we be needing a router. When we're doing a wide area network, we need a router to send the signal for far transmission, overall transmission. Is that okay? Now let's move on quickly. Now we talk about the design issue. When you're designing your network, there are some issues that will arise. This issue, we need to know them as a network administrator and be able to handle them as they come as challenges on the field when you start doing your engineering work. Now, wireless LAN have a maximum distance the signal can be transmitted, right? Wireless LAN has a maximum distance that the signals can be sent to. Now, this is a critical issue inside building. Okay, within a building, you have different floors within a building. So there are maximum distance you can send. So what we do, we need to include a lot of access points in order to mitigate against this problem. In order to mitigate against this problem that we arise within the same building in different floors, and the distance already you have out numbered your distance. You have outclassed your distance. So you need to how to mitigate against that problem is for us to include multiple access points in order to keep providing signal strength as it were within that same building. Now, this is a critical issue inside a building. Within a building, we always have the maximum range the signal can go. Beyond that, the signal can no longer go. You cannot have only one access point for multiple floors in a building. So you need to create multiple access points in order to ease user mobility within the network. Okay, so these are design issues that you should keep put into consideration when you're designing a LAN. Okay. There are many obstacles that reflect and attenuate your signal, causing reception to suffer, causing what you have sent, your transmitted data packet, to suffer reception at the other end. There are many obstacles. These obstacles, they cause what we call reflection. We've talked about reflection in chapter 2. We're talking about reflection and attenuation. We've also talked about attenuation in chapter 2. Attenuation, the degradation of the signal strength as it travels from one point to another. So we need to mitigate against all this problem that we arrive in practical sense where we are doing the engineering in the field. Now, also the signal level for mobile users is hampered by the increased distance from the access point. So since your signal level is going to decrease very significantly, then the one of the ways to solve this critical problem is to create multiple access point as you travel within the same building or from one building to the next building. For the next building, we'll be talking about the outdoor point to point or point to multi-point wireless network. Okay, we'll be talking about outdoor, because if it's from one building to another building, we'll be talking about the distance will be taken to cognizance as a function of the distance will be taken to cognizance as a function of the outdoor point to multi-point wireless network. Is that okay? So let's move on quickly. Now, this is exactly what we're saying. Let's assume this place is one floor in your building. This is another floor in your building, probably another floor. There are multiple floors in your building. Okay, so as you travel from a floor to floor, you begin to suffer. You see, the user is traveling with this line, is traveling down the LAN, is traveling down the LAN local area network. So what you need to do is to quickly understand that as you travel, one access point may not be enough to provide the desired excellent signal strength that is required. So what you need to do is to increase multiple access points to solve or mitigate against this problem. Now let's move on quickly. Now, RF study. Let's talk about RF study, radio frequency studies. Okay, we need to do this in order to know how where and when to put multiple access point. You cannot just put access point wherever you like. Okay, because you don't know if whether that area is suffering is low signal strength, having low signal strength, or it has a very excellent signal strength. So you have to carry out the RF study within the building, floor to floor, level to level, whatever it is, distance to distance, to map out where you have low signal strength, and then you will be able to know where to include an access point, an extra access point. So it is very important and very significant to verify that the sufficient RF signal level is available for the user in the wireless LAN. This is best accomplished by performing what we call the site survey. You must carry out what we call the site survey within the building or within your geometry, whatever you are considering. Okay, now inside the building, a site survey is performed to determine the best location that you can place a extra access point or other multiple access point for providing maximum RF coverage for your wireless client, for providing maximum RF coverage, signal radio frequency signal availability for your client. Okay, so site surveys are also done with outside installations to determine the coverage area. If you're doing for outside, is to cover the coverage area where your signal can travel to, or the area you can cover with outside the building. Is that okay? Now let's move on quickly. Now, site survey issues, the challenges, or the things that you have to look out for when you're doing your site survey. The key important issues that you have to put into cognizance when you're doing your site survey in your indoor concept and even outdoor installations are: one, first of all, let's take a look at the indoor. First of all, you have to look at your electrical power. So where's your electrical power? Okay, you have to put that into cognizance. Wire network connection points. Where are your wall plates? Where are they located in the building? Then your access point placement. Where is it placed? Okay, what is the maximum distance away from the access point before the next access point? So you have to establish all of this. If the signal, which of the 802.11 are you using? 802.11b has a maximum 70 a maximum this 150 feet that the signal can travel. If it's 802.11a, has a maximum distance 75 feet that the signal can travel. So you have to keep all this into cognizance in establishing where next or where best you should put the next access point in order to create increased connection for your clients and users in your network. Then you also have to consider the bandwidth support, the channel support, the bandwidth support. Okay, what type of bandwidth are you talking about? So to know where next to put your next access point. Now, if you're considering the outdoor consideration factor, putting into cognizance, then you have to look at your electrical power, your base access point. Where is your base access point, and where are other multiple areas where we can put access point in order to increase connection or connectivity within the system. Connection back to the home network. Okay, you must establish how you can get connection back to the home network. Then where should you your antenna, rooftop usually best, rooftop, or things like in height position. You place your antenna in height position in order to eliminate the reflection, attenuations, blockage, and so on and so forth. So your antenna selection, locations, where you place them for the outdoor transmission. Then the bandwidth supported. What type of bandwidth? Is it 5 gigahertz bandwidth, or is it 2.4 gigahertz bandwidth? And then the RF coverage also, how far this can go, or it's be covered, the signal strength can reach. Okay, you have to establish all this when you're doing your site survey for both indoor and outdoor in order to know where next or where best to next you're supposed to put your next access point. Is that okay? Now let's move on quickly. Now this is a typical example. This is a building floor for your site survey. Now you can see we have an access point 1 here, and then we have another access point here. So depending on which of your wireless network you're using, if you're using IEEE 802.11a or 802.11b, is one of the factors also to consider. Now you can see a location here, your point, your maybe user point A, user point B, user point C, user point D. Okay, these are about 4 users in this floor. We identify 4 users. Now this user, we have a SLS signal here, right? Because it's very close to access point 1. User A, we have excellent signal because it's very close to the access point 1. Probably signal B may also still have a signal, but not excellent, maybe good. The rate of the signal may be good, which we're going to go through. But see, when you're getting to C will not get a signal, or even if it has, it will be weak, because access point 1 is very far from C. You can see it's very far. Even if there is anything, it's going to be very weak. And at D, you don't get even any signal from access point 1. So hence, after doing this testing, then you now recognize or realize that you have to put another access point that will help C and D to give them SLS signal strength. To give them SLS signal strength. So that's what it is in a building. So this is the testing. So you, in the first case, you test for A. You see your user A. You test because this is your access point 1 here. Okay, this is access point. Let me move this one to this side a bit for now. So this is your access point 1, right? This is your access point 1. This is your access point 1, and then user A get SLS. If you see the signal strength, let's see here we have the Ethernet address, the Ethernet, like the MAC address. Ethernet address is also called the MAC address. This is the IP address, okay, Okay, this is the network driver status. Okay, so it says loaded. Now you can see the signal quality. Say excellent. Signal quality excellent. Why? Because the user is close to access point 1. The user is close to access point 1. The user is close to access point 1. So the signal strength is or quality is excellent. What's the speed? Is 11 megabit per second. So 11 megabit per second. This is 802.11b. This is 802.11b. The speed of this is 11 megabit per second. So you can see it's using IEEE 802.11b standard. Okay, that's what we are using. Okay, so that's what you see from this radio, the RF radio frequency signal level that is observed at point A. That's what we see. Now let's go to point B. What do we see? In point B, okay, this is still on A. A we say is excellent, right? We say the signal strength is excellent. Is excellent. The speed is this still on A. Is giving you the speed. Is giving you. It say the signal quality is excellent. Look at it here. We still on A. You see it's full. The bar for the signal is full. You can see it's 100%. It's 100%. So we say signal A, the signal is 100% and its full quality is excellent and is super good. Now let's go to at point B now. When the user is at point B, what happens when the user is at point B? When the user is at point B, you look at the signal. The signal is good because a bit far away from the access point 1. The signal, the user at point B is a little bit far away from the access point 1. The signal is good. It's not excellent. It's good. It's considered good, but it's not excellent. And the speed is still the same, to 11 megabit per second. And then you can see it only uses 6 out of the 2.4 gigahertz. 6 megahertz out of. Okay, 6 is for the channel. Okay, sorry. Channel is 6, and the frequency bandwidth is 2.4 gigahertz. Okay. So you can see, now let's take a look at this. You can see now we are displaying the signal in plot to see the signal quality. It's good, it's not excellent, it's not full, it's not 100%. It's dancing between 50%. So okay, so this is at C. At C the signal is a bit weak, right? The signal is a bit weak, it's not good. Right? At point C, it's fair. We say fair. We say the signal is fair. It's not excellent, it's not good. Why? Because the user at C is a bit far away from access point 1. It's far away from access point 1. You can see the distance. It's far away from access point 1. So we say it's fair. It's not good enough. The speed is still the same thing. Now let's go to D, at point D. When you are in D, what happens? When you are at point D, D is far away. Further away than C. You can see it's way far away. Now what do we see here? Out of range. Look at the signal quality. Out of range. Out of range, there's no signal. Out of range, it's out of range. There's no signal quality here. Okay, so you see, we say it's disabled. We say it's disabled. Out of range, there's no signal at point D. So it's out of range, and it's a loss of association, meaning that your computer adapter, your network adapter of your particular PC is not accessing the access point. It's not connected, it's not associated with the access point. So there is no connection between your adapter and your access point. So you cannot send any data packet, and the data packet cannot be received anywhere. So hence, as an engineer or a network administrator, then you know that you need another access point to create a signal strength that can provide service to C and to D. Okay, automatically. Okay, so that's that. Now that's what we see. Now you've seen from your survey that access point 1 is not able to cover user A, user B, user C, and user D excellently. User A was covered excellently. User B was just good. User C was fair. User D was out of reach. There's no there's no connection. There was a disassociation from the access point. Hence, we need to do another one called the access point 2 in order for this floor to have a good signal strength. Is that okay? Now let's move on quickly. Okay, so like I've already explained, we say we need a secure access point to provide that necessity, to provide that necessary connection at point C and at point D. Okay, so with this, I think we're coming to the end of this subsection. These are the big terms that we've used: SSI, the service set identifier, and the site survey in the wireless networking. You know, this chapter is about wireless networking, a practical wireless networking. So with this, we come to the end of this chapter, and thank you for joining us today. Thank you. Thank you very much. We appreciate it.